Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and today we're going to talk with Will White, Solar Application Specialist at Fluke. Will, welcome to the program.
Thanks, Chris. I'm excited to be here.
I am happy to have you on the show. As I alluded to in our pre-call, I wanted to start out with what exactly is a solar application specialist at Fluke or anywhere? It's not a term I'm familiar with. So what is it that you do?
Yeah, that's a great question, and it's a term that's kind of unique even within Fluke. So basically, Fluke, we're a manufacturer of test and measurement equipment, so multimeters, clamp meters, thermal imaging cameras, things like that. And we've moved into the solar industry, but before I joined Fluke, there weren't a lot of people on staff who had experience with solar energy storage, electric vehicle charging. So essentially, I am the on-staff subject matter expert for anything renewable energy, solar, energy storage, electric vehicle supply equipment, microgrids, all those technologies.
And so you have measurement equipment, and we've done a number of episodes in the past on solar and maintaining solar and things like that. Um, where do you spend your time? What kind of things are you looking at, or what does the solar energy industry need measurement equipment for?
Yeah, it's used for many different things. Test and measurements done in the installation process of solar and energy storage. We see it a lot in commissioning, and then especially in operations and maintenance while they're maintaining the system. If there's problems with the system, they're going to need to troubleshoot, so they'll use test and measurement equipment for that. Even just in regular making sure everything's working properly, that's where we see the applications for our products.
So is the problem statement that you're coming across when commissioning that you don't want to have your equipment catch on fire or have your solar panel melt, or is it that you want to see the performa based on the investor's criteria? What kind of things are you looking for?
Yeah, all of the above. Once an installation is done or finishing, they commission the system to ensure, first off, that everything's working right to begin with, catch any problems before they turn the system on. For us, what our tools are used for a lot is actually recording data to set a baseline. So they know on day one, everything actually worked the way it was supposed to, and then they can use that to go back in the future when they're if they run into issues with the problem or issues with the system. They can look back and see, okay, what was the measurement when the system first started up, so they have that historic data there.
When you start a system up, are you comparing a baseline to manufacturer's recommendations or like engineering calculations? So you'll figure out the impedance of the wire, you'll figure out everything there, and you kind of go, okay, we should be seeing this kind of voltage going through here, and we're not. And you fine tune it to get the baseline, or are you just looking at reality and just saying, okay, this is the baseline?
It's a little bit of both. So they have designs for the system, so they know what the operating parameters are. They'll go through and do simple checks like voltage testing. Testing polarity, surprisingly, is a simple but very important test. Insulation resistance testing to ensure that the wires haven't been compromised during the installation process, and then IV curve testing, which is a test specific to solar modules to ensure the module or the string of modules is operating properly.
All right. So for me, who doesn't know what an IV curve testing is, what does that entail? I mean, how sophisticated are these tests, and what are you doing?
It's a very specialized test for solar and specific to photovoltaic modules. So it's testing the voltage and the current of the module and graphing a point between the two to ensure the module is operating properly. In a normal IV curve test, you'll get a nice curve and then you can see where the power is, which would be at the knee of that curve. When you have issues with the module, there'll be discrepancies in the curve. So there might be a notch in the curve, or voltage or current are reduced. So you can see things with an IV curve that you wouldn't be able to see with normal voltage or current testing.
Now, your engagement, you said, is kind of the construction and through the project. How do developers, solar developers, or project leads interact with you? Are you brought in the planning phase? Are you brought in early? Are you on a contract throughout the life cycle of a solar project? Where do you fit into this equation?
Yeah, that's actually not something that I typically do, or Fluke does. We'll be brought in to discuss test and measurement options and the tools and the different tools that we provide and how they can implement them in the field. There are companies that will be brought in by these contractors, by asset owners, by financiers who will do the test and measurement. Another part of my job is training. So we do a lot of training with technicians, with our distributor partner, with our sales team, and with people working in the field on how to use test and measurement equipment effectively and, most importantly, safely while they're out doing the actual work.
So training's a good point that to come up, and I think we talked about this as well when we spoke initially about
Mhm.
the staffing of people. If you look at the growth rate or projected growth rates for solar, you need a lot of people, right, to be
Yeah.
brought into the industry. Um, and the skill sets need to be there. So is using test and measurement a fundamental skill set, or is this maybe your advanced troubleshooting team? Is every installer going to need to be able to use a tool set like a Fluke or some other device, or only certain skilled people on a team?
Yeah, it actually goes across the spectrum. So everything from electricians just wiring up modules who need to do basic voltage testing and polarity testing, all the way through to the specialized tools like IV curve testers or power quality analyzers on the AC side of the system. So it really does go across the board. And to your point, there are right now the last solar job census showed that there was about 263,000 people working in the solar industry. But SEIA, the Solar Energy Industry Association, predicts that in order to get to the 2030 climate change goals, to deploy enough solar to be able to meet those goals, we're going to need about 1 million people in the solar industry by 2030. So, I mean, that's a 4-time growth from where we're at now. So, yeah, bringing all those people in the industry, there's definitely a lot of training needs there.
Now, the kind of tools that people are using in solar projects, are these like IoT tools that sit in throughout the life cycle of the project, or is this something I'm just clipping some alligator clips onto something and testing as we go along the way?
Yeah, there's both. So most systems, especially when you get into the commercial and the utility scale systems, the larger ones, have data acquisition systems that are constantly monitoring what's going on with the system from the DC side to the AC side. So the asset owners know what the state of the system is pretty much at any time, 24 hours a day. Even when you get into residential systems, each inverter has its own monitoring platform. So homeowners can pull the app up on their phone, see how their system is producing. Um, Now, when you get into the technical side of it, of the installation and the troubleshooting, there are tests that we do with handheld standalone meters that go above and beyond what those data acquisition systems can provide.
I guess I'm still not totally around what we're testing for, right? I guess you could see performance, overall performance should be a
Mhm.
pretty straightforward test, right? Did you have your baseline and 6 or 12 months, you come back, you take it, and you see that you're getting less energy out of your or less efficiency out of your system. Um, what are the kind of advanced type of tests, and where are they bringing value to who?
Yeah, when you are troubleshooting, or even just doing regular maintenance on large scale systems, usually commercial or utility scale systems, a lot of maintenance professionals these days are using aerial thermography, using drones. So they'll send a drone to fly over the array taking thermal pictures. They'll take that photography and they'll usually put it into a software that can analyze that photography, and then they'll use advanced AI and machine learning to identify specific sections of the array that are having issues. And then from there, they'll go and dive deeper into the array and go to that specific point that's having a problem and do further testing. And depending on what the potential problem is, there's various tests they can use, things like voltage and current measurements, the IV curve tracing, which we talked about, even thermal imaging at a specific location to maybe look at connectors between modules. There's all kinds of different diagnostic tests they can use depending on what type of issue they're running into.
Now, is this generally a field job? Is this someone going out to the array? So they're out in the field, they're bringing this equipment and doing the testing
Mhm.
remotely?
Yeah, they're doing it in the field. The larger systems do have monitoring that is um, monitored 24 hours a day, especially on the larger systems. So though the people who are, say, in the office watching those systems, ensuring that they're operating properly, they'll get warnings from the system. So they'll have those warnings come in, and they'll dispatch those to the field operations and maintenance team to go in and really kind of figure out what's wrong with those, what's causing those issues on the monitoring platform.
And what kind of skills does the average employee to use the tools need to have? So you said you do quite a bit of training.
Yeah.
If you're someone looking to get into the solar industry, and a lot of solar installations in the U.S. are still kind of mom and pop operations coming in, um, what skills would someone need? And would this be a way to maybe accelerate someone's career by getting these kind of skills? If they said, "Hey, I want to be a solar installer, or I want to do
Mhm.
some solar troubleshooting," what do you need to do to understand what kind of work you're talking about?
You know, it's really interesting because it's changed over the years. I started in solar in 2005. I worked for a solar installer for over 10 years. Started out, literally putting modules on roofs. Moved into management, was crew lead, and then project manager, and eventually became director of operations for the East Coast. And when I first started in solar, the operations and maintenance and troubleshooting technicians were always the most experienced field people. So you'd take someone who'd been in the field for a couple of years, they had gained that experience working with systems, and you'd move them into that kind of troubleshooting role. But the industry's really changed. We talked about the growth of solar and how we really need to bring more people in the industry. And it's gotten to the point where operations and maintenance companies are really hiring pretty much anyone with some kind of technical background. It's nice if they have a background in electrical or some type of construction trade, but many of them are willing to train people if they're, just have the interest and the desire to get in the industry. So yeah, it's really that dynamic has changed quite a bit over the last 17 years since I started in solar.
So also, has there been a shift now? I mean, you have a fairly long history in the solar industry, especially in North America, for the kind of growth. Are the manufacturers considering kind of testing and the equipment? Is that changed from how it was earlier? Is there any difference when I buy panels and when I buy the equipment than there was maybe in 2005 with consideration of performance and testing metrics later?
The modules are more or less the same. I mean, the technology's changed a little bit. It's constantly advancing. They're more efficient than they were when I started. Inverter technology is where some of that has changed. We are seeing better monitoring at the inverter level, in the inverter manufacturers offering features that allow for better monitoring. The inverter technology has also changed from when I first started to now. So we have inverters now that are safer, that do testing at the beginning of the day that didn't used to be able to be performed by the inverters. So we have some more advanced features there that doesn't necessarily eliminate the need for test and measurement equipment out in the field when you're doing troubleshooting, commissioning, things like that.
Now, test and measurement equipment, is this kind of standard that people all be carrying it, or is this expensive enough equipment that you have one that goes multiple job sites, or does every job site have this equipment with them when they're going to do an install?
Yeah, it depends on the piece of equipment and the test that's going to be performed. Um, all electricians have multimeters, clamp meters for measuring current. So that's a type of meter that everyone has. We usually call those tech tools. Every technician has one. And then there's a kind of another set of tools that are, we call them like shop tools or truck tools, where there's one for the team or for the area. Things like thermal imaging cameras, power quality meters, IV curve tracers that are more expensive. So you kind of have both. Every technician should have, it has to have a multimeter or a clamp meter to measure simple things like voltage and current, uh, polarity, things like that.
And then when I go back to skills and training, with all the talk of AI going on, and you mentioned it before, um, I would suspect that getting solutions suggested from a tool would be relatively easy today, or things to look for because of AI and having a large data sample size to say, hey, if this is happening, check these things. Do you see that happening in reality, or is it still mostly up to the tech to decide what to do with the data points they're getting?
It's definitely shifting. So it historically has been the tech needs to know how to do math, know exactly what they're looking for and how to test for certain things. It is moving now towards the tools being smart enough to be able to say, okay, here's the measurements that you took. Instead of you having to manually do the math, we'll do the math for you and give you some information. We're not quite there yet. It's starting to get that way. We see things added into technology, test and measurement equipment. Like we have a multifunction tool that will perform lots of different tests in solar, and it has an info button on it. So you push the info button at whatever test you happen to be at, and it gives you a graphic of how to set the tool up. So things that make it a lot easier for the technician. Now, it's interesting. I've attended an operations and maintenance and asset owner conference for the last 2 years. And 2 years ago at the conference, the big discussion was labor shortages. We just can't get enough people in the industry to do all the work that we need to do. And this past year, the conversation was still there, still massive shortages in labor, but the dynamic changed a bit to how can we use technology to make it easier for the technicians, to require fewer technicians, to automate those jobs. They didn't necessarily have any answers to those questions of how to do that yet, but the conversation has definitely started. How can we use AI? How can we use machine learning, automate things just to make it easier? So the conversation is definitely out there, and the industry is moving in that direction for sure.
So it sounds like there's demand, but the solutions haven't been delivered to market yet or at scale. Um, the second thing, and I think we talked about this, we alluded to it already in the conversation, but it was in our pre-show conversation. What's the importance of doing this in utility scale solar systems? Why, when we're deploying, do I need to do this? What are the impacts of not doing this kind of testing, and what are the risks of not doing it? So maybe we understand. You know, we went right to bits and bytes, right? We started talking about meters and testing and things like that. But so I've got a new install. It's solar scale. It's a scale, utility scale kind of deployment.
Mhm.
What are the risks of not doing this kind of testing? What happens? What can go bad?
Well, financial loss is the main risk, and when you're doing commercial and utility scale systems, financial benefit is the motivation of the asset owners and the financial backers. It's a business that makes sense. So, not maintaining the systems, there's lots of things that can break down. First off, just simple things like vegetation management. You know, uh, Grass, trees growing up in the array that's going to shade the array, it's going to reduce the production. Then we've got things like our inverters, especially on the larger scale inverters, they have annual maintenance requirements. So there's filters that filter dust out through the ventilation system. Those need to be cleaned or changed. Just looking at the system and making sure that things are working properly. If you don't maintain these systems, they're not going to operate the way that they're designed to be. And doing regular annual maintenance, just even getting out there and doing a visual inspection, will catch a lot of problems and prevent issues from happening in the future. Even on the residential scale, when I first started in solar, and I hate to admit this, but this was a very prevalent thing in the industry. We used to tell customers that solar is basically maintenance free. You throw the system up on the roof, 20, 30 years, it's going to be fine. and that's turned out not necessarily to be the case. Residential doesn't necessarily need as much operations and maintenance attention as the larger scale systems do, but it's good to have the system checked out every 2-3 years just to make sure everything is working properly. We'll definitely avoid problems in the future if you catch things early.
So in utility scale, I would expect there to be a storage component. And in residential today, as we move forward, I think more and more people are leaning towards storage, or the trend will be. I don't know that's the actual trend yet. Um, how does that play into? Is the storage an important component to this process?
Absolutely. One thing with solar is obviously the system makes the most amount of energy when the sun is shining. That typically is the middle of the day. So the utility load also tends to be, especially on the residential side, relatively low during the day, where most people are using things in the early evening and into the night. Energy storage allows a couple things. First, it gives us resilience. We can use it for backup. So if there's a grid failure, you have power when that grid is no longer available. But what energy storage is also allowing us to do is to store the energy generated by the solar during the day and allowing us to use that energy at night where the solar's not producing, but we have a high demand. So you're absolutely seeing solar or energy storage deployed with solar on the utility scale and in the residential scale as well. We see markets like Puerto Rico is a great market. We call it the attachment rate. That's how much battery storage is being installed with solar, and the attachment rate in Puerto Rico over the last year or so has been about 98%. So almost every residential system installed in Puerto Rico comes with energy storage. When you look at other markets like California, they're at about 20 to 25%, and even higher in some areas like the San Francisco Bay Area. So yeah, we're absolutely seeing energy storage becoming more popular for several different reasons, and I think that will continue to be so.
Well, I think that ties into where I was going to go next is, policy and legislation, things that
Mhm.
go there, right? So is policy and legislation or interconnects and all the pieces you need to make this work, is that in place today, or is there a lot of work to do on that side to get to the kind of connect rate that you just described of Puerto Rico or
Mhm.
somewhere else? Is the legislation gating, or is it an economics gate?
Most people are doing solar and energy storage for, well, solar for economic reasons, energy storage sometimes for economic reasons, but a lot of times for that resilience, to have that backup and knowing that you'll have power when the utility is down. Now, as far as legislation, it really is jurisdiction to jurisdiction, state by state, really. So some states are a lot easier to work with when it comes to the legislation they're putting it through. Others are more challenging. We are constantly working to get pro solar legislation through on state levels. Organizations like SEIA, the Solar Energy Industry Association, is our trade organization, and they have branches in pretty much all states. Every state, more or less, that I've seen has some type of solar energy trade group. I'm in Vermont. We have Renewable Energy Vermont here, which is our SEIA affiliate, and there are affiliates or trade organizations in every state. So they're working hard in the state level to ensure that we have legislation that it makes it easier for solar. We also see other groups, fighting against it. So it's a kind of a constant back and forth battle there to get pro solar legislation through.
Have you seen any change in demand in the market due to interest rates going up? Is that impacting the solar performance that you're seeing right now?
I haven't seen anything or heard any industry chatter about interest rates impacting solar. We did get the Inflation Reduction Act, but this time last year, which extended the 30% federal tax credit for both residential and commercial systems. That's legislated through 2032. So we've got 10 years of 30% tax credit stability, which is been a huge benefit, especially on the larger scale systems. So that's the biggest change that's come around as far as the incentive side and the financial impact.
I always like to have on this program some real world examples. So maybe you could share from your experience of where this kind of testing has made an impact, and share a story or use case that you've seen, and what the outcome was.
Yeah, so testing and measurement in solar and impact. Let me think of see if I can think of a story here. I can't think of anything specific other than like residential ones that I've worked on, or well, I'll tell you an example of a residential system I had, and this is a story from when I was installing solar. Did an installation on a residential system. Then the customer was complaining of weird things happening, um, different like lights flickering, their ground fault outlets tripping. So we went out, did some testing. We did some voltage testing and ended up pulling out a power quality meter and doing some power quality tests. And we found that the utility coming from the voltage coming from the utility was really high. And it turned out that the utility was had taken the substation in their town offline to do some upgrades, and they were pushing voltage in from a substation 2 towns over. So they were experiencing really high voltage at the customer's house. So we were able to identify that, through that test and measurement process, and we're able to adjust the inverter settings to be able to accommodate that. And eventually, they fixed the substation, and the problem went away. But test and measurement can find all kinds of things. Thermal imaging is a really great example. When I started in solar, a thermal imaging camera was prohibitively expensive, so we didn't really have them. Now you can get thermal imaging cameras. I mean, we have a pocket thermal imaging camera that's $1,200. You can even get ones that are less expensive that plug into your phone. Um, with that information, with that tools, you can see things that you wouldn't be able to see otherwise. Modules will be hotter than I should say, a module that is not functioning properly will operate hotter than a module that is functioning properly. So it makes it really easy to troubleshoot solar panels that are having issues. Um, with electrical equipment, you can see things in, say, a combiner box where strings of modules come together and are connected, and before they go to the inverter. With thermal imaging, you can go in there, you can see one's circuits that are maybe hot, that maybe have somebody didn't tighten the connector down properly. You can see ones that are cool, where maybe a connection in the array broke and that string of modules isn't producing any current. Really great ways to use that equipment to very quickly identify problems in the field.
Now, I guess when you're talking about all that, I think of like microgrids and all the components out there. So for industrial scale or for utility scale, either one of those, I'd expect you have some sort of specialist on your team
Mhm.
that would handle that. Residential, I think you would have someone else managing your solar, that you wouldn't be out there with a camera monitoring your system. Maybe some owners might be that passionate about it. Um, but are enterprises having people with these skills in house, or as you said in the beginning, the installer was an electrician that came out that they hired?
Mhm.
Where are these skills coming from, and do enterprises realize that these skills are important to them? Are there enough economics to make a job description that they would care about this?
Yeah, there absolutely is. Um, it's interesting. The market is really segmented, especially on the larger scale. There are people who are just doing installations, and even that's broken down into people who just install racking, people who just put modules on racks, and then to the more skilled electricians who are going through and doing a lot of the electrical work. When you get to the operations and maintenance side, there are companies that have in-house operations and maintenance teams. There are companies that use third-party operations and maintenance teams, and that could be everywhere from the small mom and pops that you mentioned up to national companies or even international companies that are providing services literally around the world. So we've got kind of a mix there, but they're definitely recognize the value of skilled labor. And one of the really nice things about the solar industry is it can be a very lucrative job. There's the pay scale is really good. Often the benefits are good as well. When you get into those larger utility scale projects, a lot of them, especially when you get above about 50 megawatts, have on-site staff that their job 40 hours a week. They're on that site, maintaining and doing troubleshooting, just working on that site year round. So it's a nice, stable job.
And that on-site staff goes back to the training and labor question. But we see there are people to fill those jobs today. Or are we seeing vacancies in those kind of roles today?
There's a lot of openings. Absolutely. And it's almost across the board. Every company that I talk to, be it installers, developers, operations and maintenance companies, even onto the software and the construction and manufacturing side, they're all hiring. So there's opportunities across the board. And yeah, like I said, it's not just people working out in the field. There's opportunities in other things like sales and marketing and distribution across the board. People are hiring in solar.
But the folks that you come in contact with, the kind of role that you're doing, are more operational folks. Is that what you would say? Who you engage with mostly
They,
today?
yeah, they are. That I mean, that's my background. I came from the operations and installation side, and after working for that company for a little over 10 years, I went to work for Solar Energy International, which is a training provider, and that's more technical training, hands-on training, the theory behind solar and what goes into the parts and the pieces and how it all fits together. So yeah, that is who we typically work with, since in Fluke, test and measurement equipment's being used by the technicians in the field, although they are used in manufacturing as well. So we see an application there too.
And what's the magnitude of cost of this kind of equipment? Like what is a test set composed of, and what magnitude of cost is it?
Yeah, it varies. There's a wide range. So Fluke, everybody knows Fluke equipment is a premium tool. We make high-end equipment. It's very safe. It's third-party tested. So our tools are going to be a premium cost, but there's also the quality there. So we'll see everything from multimeters that can run for a couple $100, anywhere from probably 250 up to $700 or $800. When you get into the more expensive tools like thermal imaging cameras, again, those can range from about $1,200 on the low end up to $15,000. Test and power quality analyzers are in the ten to $30,000 range. So it's a pretty wide spectrum depending on what tool you're doing for what type of test.
Now, is this generally so developers, when they do their initial PPAs and contracts for
Mhm.
utility scale, the performance already been done. So it's hard to come in later and add cost, right? Because
It
once
is.
you've built your project, nobody wants to degrade their returns that they've been committed to based on the performance. So, are you seeing these tools as line items then on the project front end, or are you trying to have to go back through once they find there's a problem that developers are coming and go, oh shoot, we should have kept another $20,000-$30,000 for tools to maintain this thing?
We're not seeing line items actually in the contracts for test and measurement equipment, more for general operations and maintenance. And to that point, there was I'll call it a severe underestimation of the money that goes into annual troubleshooting and or annual maintenance and reactive troubleshooting. And hopefully we're starting to see those developers and the asset owners come around to realize that you really do have to set some money aside to maintain these systems in order to ensure that you're going to get that financial return. If you don't maintain them and they don't work, you're not making any money.
So, is there a back of the napkin kind of calculation you do? So, if you're putting in, I don't know, X size, solar array and farm, some percentage of the total number that you go for operations annually, or is there kind of that kind of calculation taking place?
Yeah, there is, and I'm not connected enough to that development front end side of things to know what that number is, but there is typically it's a price per watt estimate of how much the annual maintenance expense is going to be. So yeah, they've got ideas about how that's going to play out, and I think we are also getting better data on the back end of seeing, okay, well, how much do we actually spend? Solar's been around long enough at this point where a lot of these developers and asset owners have done enough projects where they can see, okay, that 5 or 10 years of this system actually operating, let's look back and see how much did we actually spend versus how much we thought we were going to spend. So there's a lot of that analysis going on now too.
And then for the people that do these jobs, I would suspect that as we get more and more deployed projects, that their skill and their value price might go down because you have more and more competitive people that have these skills. So do you envision these remaining high paying jobs into the future, or with AI and with lots more alternative choices and people having these skills, does the value of a troubleshooter or someone, technician decrease in the future or go up in the future in your experience?
I can't imagine it would ever go down. If anything, I think it will go up. And we may see, and we have seen this over the last couple of years. If you look at the employment figures, they've been relatively stable from the, I don't know, 225,000 now up to about 263,000 people in the industry. So labor has stayed relatively stable, but deployment has gone up. So we're seeing efficiency in labor, absolutely. And when I talked about those people who are talking about how we can leverage technology to reduce the amount of labor, it's not because they want to get rid of people. It's because they want to make it more efficient because we can't hire enough people in the first place. So it's not like we're going to be laying operations and maintenance technicians off because now we have AI. Someone's always going to need to be out in the field. AI is not going to go out and replace parts and swap out filters and inverters and do troubleshooting in the field. At least not anytime soon.
So how does this compare to, let's say, an electrician needing to get licensed in a state or whatever? Are folks that working with these kind of voltages? I mean, because a utility scale is a lot of power running through there, right?
There is.
And if you don't know what you're doing, it could be dangerous. So, are there licenses or is there association certificates that people have, or how are people bringing in people that are qualified and making sure they have the skills?
Yeah, most states require electrical licensing, most if not all. So a lot of these technicians, if not definitely the majority of them, are licensed electricians. We do see a lot of companies, or maybe not a lot, but we're seeing companies starting up their own apprenticeship training programs. I was out in the field with a company a couple of weeks ago where they were having so many problems finding qualified electricians and getting them through the training that they developed an in-house training program. So the electricians are out in the field. These are the apprentice electricians. They work Monday through Thursday. They do 4 10s, and then on Friday they're in the shop in their classroom, working with the journeyman and master electricians to go through the training that the classroom training that's required. Um, all paid by the company. So this is a great way to advance, skills and gain that license. And the nice thing about having that electrical license is that skill, you can take that license pretty much anywhere. So if solar should for some reason go down, which we're not foreseeing that happening anywhere anytime over the next decade, you can still go do traditional electrical work. So that license is very valuable. In fact, you know, I I started in solar as a doing roof install work, and I wish I had gone the licensed electrician route. That really does having that license really does increase your interest from other people looking to hire you. It also increases your pay scale pretty significantly.
Now you mentioned math, right? And I think it's hard to do renewables without math, whether if
Mhm.
you're calculating load or what's going in. What kind of math skills um, do folks need to be successful in the solar industry?
It's honestly pretty basic, but that's a good point. That's something we really struggled with at Solar at SEI, Solar Energy International, where we were doing training because a lot of people haven't done math since middle school. In some cases, and basic math is really important. So I developed a class for SEI that's free. It's the fundamental math for solar. So people can go on the SEI website and take that class anytime. But it's basic stuff. So converting decimals to percentages, converting percentages to decimals, um, basic orders of operation, PEMDAS, if you want to go back to basic algebra. So yeah, orders of operation, basic just addition, subtraction, multiplication, and division. So we're not doing any like high end statistics or even mid-level algebra. It's pretty fundamental math, but it is important to know. It's important to be able to go out in the field and say, okay, I've got a module that is a certain voltage. I've got 22 of them in a string. What's the string voltage going to be? And then I've got multiple strings connected together in a combiner box. What's the output of that combiner box going to be? So it is fairly fundamental, but critical. I mean, you can't do it without knowing some basic math.
And are you finding, I mean, you put a class together, are you finding that most of the people trying to get into us have the capability and have the fundamental foundation? It's just rusty? Or are you teaching people from zero to do math? I mean, they
Yeah.
just don't have any and weren't interested in it when they were in school.
It's totally across the board. And we get people from all types of backgrounds coming into solar. So, I mean, there are people who didn't have a great school experience. They might have dropped out of high school. They probably haven't done math since middle school. All the way through to the opposite end of the spectrum, where people who've got master's degrees coming into the industry. So, it's kind of across the board. But yeah, having those basic math skills are pretty important.
And for somebody that wants to get into the industry, you talked about apprenticeships, you talked about some math class online.
Mhm.
What what's the expectancy to get into it? So if you're in another career or you're just out of school and you're looking saying, "Hey, there's a great future here. I hear there's demand." How long does it take to actually get into where you can get a reasonably high paying job in energy?
Yeah, I mean, I'll I'll tell you what we like people to have, and then I'll tell you the reality. So it's nice if people have some kind of construction background. If you're going into the operations side, some kind of construction background, maybe some carpentry experience, some electrical experience. If you're going into the more office types jobs, some kind of background in marketing, sales, management, whatever type of business types skills you've got. So that's what they like. Um, NABCEP, the North American Board of Certified Energy Practitioners, has a associate's level certification. It's a credential where people who are interested in getting into the solar industry can take some courses, do a test, credential, and that shows that hey, I know some about solar. I'm invested, ready to get into the industry. Now the reality is the industry is so desperate for labor that if you have a clear criminal background, even in a lot of cases, if you don't, there are companies that can work with that. They're really looking for people who are dependable and who will show up every day on time. Honestly, that's kind of the bar for labor at this point. So it's very easy to get jobs in solar, especially if you're reliable.
All right, so we've covered the human capital aspect. We talked about the tools available as we're getting up towards time. How do we bring this all together? What is your take of, hey, you need to do testing. You probably need to do it in setup. You need it operationally. Maybe pull this together for audiences as we come to the end of this episode of what your take is on the tools out there and who should engage and when.
Yeah, the tools are getting better. We're getting solar specific tools. That's what we're working on at Fluke. So we have released and will be releasing more tools specific for the solar industry. So that's coming out. We're pairing that with training. Fluke, we got a course approved by NAMCEP for continuing education. So we've got tools and techniques for test and measurement in the solar industry. We'll be releasing more of those type classes coming out over the next year or two. So more training there. And then really getting people excited about the industry. There's so much opportunity. I mean, I literally started out as a solar installer, and within 10 years, I was director of operations managing a team of 50 people, spread across the Northeast. So, and I didn't have any specific training going into solar. Heck, my degree is in music business management. I mean that and I got into the industry and was willing to learn and grow, and now here I am almost 18 years later, and I've just been doing it so long that I've developed all the skill and knowledge that I needed. But yeah, lots of so many opportunities. Even looking at my career, going from working for an installer, then into training, and now working for a manufacturer of test and measurement equipment that's not specifically in the solar industry, but working for a company that serves the solar industry. Just so many opportunities out there. It's really and not I want to stress this. It's not just installers. There's so many jobs in sales and marketing, management, procurement, accounting, legal, development, contracts. There's so many different things in jobs that you can go into in solar.
Well, awesome. I like the bullish approach to solar, that you're happy about the future of where it's going to be, and the demand curves or projected demand curves are there. Well, I want to thank you for coming on this episode, sharing your experience. I think we spent a lot of time, helping people with career path choices, and a bit of time talking about the tools that would be available and how you might use them. Will, thanks for being on the program today.
Oh, happy to join you. Thanks for having me.
For our audience, we hope you've enjoyed this content as much as we did making it. If you do, don't forget to subscribe, follow us on Facebook, share it with your friends, and we'll see you again next time. Bye-bye.